Let's begin chapter 1.2, graphs of equations. Here we will be talking about the relationship between an equation and two variables and what it looks like graphed out on the coordinate plane. So, a relationship between two quantities is expressed as an equation in two variables. For example, y equals 5x plus 3. By now you guys have seen lots of different equations in two variables. Here we have a very basic example of a linear equation. An ordered pair, a comma b, is a solution or solution point of an equation in x and y if the equation is true when a is substituted in for x and b is substituted in for y. Determine whether the following points are solutions of the equation y equals 5x plus 3. The first one is the ordered pair 2, comma 13. Well, what we are going to do is we are going to substitute the 2 in for x and the 13 in for y. This gives us 13 is equal to 5 times 2 plus 3. Well, doing out the algebra, we have 5 times 2. That gives us 10 plus 3 does indeed give us 13. Because we end up with a true statement, this means that 2 comma 3 is a solution to the equation, and it is a point on the graph. Let's try -1 comma 0. To determine whether or not this is a solution to the equation, we are going to plug in -1 for x and 0 for y. That leaves us with 0 equals 5 times -1 plus 3. Well, 5 times -1, that's -5 plus 3 gives us 2, leaving us with the expression 0 is equal to -2. Now, this is not a true statement. 0 does definitely not equal -2, which means that -1 comma 0 is not a solution to the equation, and it is not a point on the graph of this equation. So, as we were just saying, the graph of an equation is the set of all points that are solutions of the equation. Here we have our graph of y equals 5x plus 3. Every single ordered pair that is on this graph is going to be a solution to this equation. Every single ordered pair located on the line is a solution to the equation. All right, sketching graphs. One technique for sketching graphs is to plot points. All right, steps for point plotting. Rewrite the equation so that one variable is isolated on one side of the equation. Make a table of values showing several solution points. 3, plot the points on the coordinate plane. 4, connect the points with a smooth curve or line. Point plotting is not a flawless representation, however, but in a lot of cases it will give you a good idea of what your curve should look like. So let's complete the table. Use the resulting solution points to sketch the graph of the equation. We have y equals 5 minus x squared, and we have several x coordinates that we are going to want to plug in. All right, let's start with x equals -2. Well, if I plug in -2 for x, -2 squared is 4. 5 minus 4 is going to give me 1. Boom, we can fill in that part of the table. Next, let's plug in -1 for x. Plugging in -1 for x gives us y equals 5 minus -1 squared. Well, -1 squared is 1. 5 minus 1 is 4. That leaves us with the ordered pair, -1 comma 4. Plugging in 0, y equals 5 minus 0 squared. Well, that's equal to 5. So we have the ordered pair 0 comma 5 on this curve. Now we can plug in 1. Y equals 5 minus 1 squared. 1 squared is 1. 5 minus 1 gives us 4. We have the ordered pair 1 comma 4. And plugging in 2 finally, y equals 5 minus 2 squared. 2 squared is 4. 5 minus 4 is equal to 1, leaving us with the ordered pair 2 comma 1. Once we have all of those points, we can plot them on our coordinate plane. There we have -2, 1. -1, 4, 0, 5, 1, 4, and 2, comma 1. Once we have plotted the points, connect them with a nice smooth curve. Now, hopefully you guys recognize that this is a parabola, okay? The equation that we are dealing with is a quadratic equation. We will talk a lot more about quadratic equations coming up later in the chapter. All right, Finding intercepts. When sketching graphs, it is often helpful to find both the x and y intercepts. X-intercepts are where the graph intersects the x-axis, where we cross the x-axis. Y-intercepts are where the graph crosses the y-axis. To find x-intercepts, let y be 0 and solve the equation for x. We're going to replace y with 0 and solve. To find y-intercepts, let x be 0 and solve the equation for y. To find our y-intercepts, we're going to just set x equal to 0. All right, find the intercepts of the equation y equals root 2x minus 1. Well, let's start off with the x-intercept. As we just said, to find the x-intercepts, we are going to substitute 0 in for y. That gives us 0 is equal to the square root of 2x minus 1. To solve for x, we need to isolate the variable, and we're going to use a series of inverse operations to get that variable on its own. Now, you might notice we have this big square root. Well, how do we undo a square root? Algebraically, we can square both sides of the equation. Squaring 0 on the left-hand side leaves us with 0 still. And squaring the right-hand side leaves us with 2x minus 1. Notice that squaring undoes that square root. Now, to solve for x, we are going to add 1 to the left-hand side of the equation. And finally, divide by 2. We get x is equal to 1/2. That is our x-intercept. As an ordered pair, that would be 1/2, comma, 0. Notice the y-coordinate is 0. We plugged in 0 for y. All right, let's talk about the y-intercept. To find y-intercepts, we are going to plug in 0 for x. That gives us y equals the square root of 2 times 0 minus 1. Well, 2 times 0 is 0, minus 1 is negative 1. We get y is equal to the square root of negative 1. Well, what does that mean? Can we take square roots of negative numbers? No, we can't. So what that actually tells us is that I have no y-intercept with this graph, all right? Y equals the square root of negative 1 does not exist as a real number, therefore we have no y-intercept. And if you were to take out your calculator and graph this function, all right, this is what the graph would look like. And you could verify that it indeed does not ever cross the y-axis. It does hit the x-axis at 1/2, comma, 0. All right, let's try another one here. Find the intercepts of the equation y equals negative x squared minus 5x. To find x-intercepts, we are going to set y equal to 0. Replace y with 0. 0 is equal to negative x squared minus 5x. Well, hopefully you're able to recognize what type of equation we are dealing with. This is a special type of polynomial. It is a quadratic equation. And how do we find zeros of quadratics? We factor. That's always your first go-to. Try and factor the expression. And so when we're factoring quadratic equations, always look for a greatest common factor first. Now, you might find it helpful. Notice I have brought the negative x squared and the minus 5x over to the left-hand side of the equation just to make everything positive. If that's helpful for you, great. Now we can factor out our greatest common factor, which is in this case between our two terms of x squared and 5x is just an x. That leaves me with x times x plus 5 is equal to 0. Once we have factored the quadratic to find the zeros, we set each one of those factors equal to 0, leaving us with x equals 0 and x is equal to negative 5. In this case, we have two x-intercepts, one at 0, 0, and one at negative 5, 0. Y-intercept. To find the y-intercept, we plug in 0 for x. Y is equal to negative parentheses 0 squared minus 5 times 0. Well, that just leaves us with 0, and our y-intercept is going to be 0, 0. Notice that 0, 0 is considered to be both a y-intercept and an x-intercept. The origin counts as both. And graphically, we can check our work using a calculator. We graph the function, and notice we have our x-intercepts at negative 5 and 0, and our y-intercept at the